The Kuiper Belt just got weird. So here's the thing about the Kuiper Belt that nobody told you in school. We thought we had it all figured out. This donut-shaped region of icy debris starting at Neptune's orbit and extending out to about 50 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, roughly 93 million miles. So we're talking seriously far out there. The Kuiper Belt was supposed to be this nice, tidy trash heap left over from when our solar system formed 4.6 billion years ago, full of icy rocks and dwarf planets, including our beloved former planet Pluto. Neat, organized, understood. Except NASA's New Horizons spacecraft, the same probe that gave us those stunning close-up photos of Pluto back in 2015, has been sending back some genuinely puzzling data that's making astronomers scratch their heads. The spacecraft has this student-built instrument called the Venetia Burney Student Dust Counter, named after the little girl who came up with Pluto's name back in 1930. This detector has been measuring microscopic dust particles throughout New Horizons' 18-year journey across 5 billion miles of space, counting every tiny grain produced by collisions between asteroids, comets, and Kuiper Belt objects. Now here's where it gets interesting. As New Horizons traveled from 45 to 55 astronomical units from the Sun, right through what should be the outer edge of the Kuiper Belt, scientists expected the dust levels to drop off. Logic dictates that fewer objects means fewer collisions means less dust. But that's not what happened at all. The dust counter kept detecting high levels of cosmic debris, way more than predicted. Alex Donor from the University of Colorado Boulder, who leads the dust counter team, said they're making the first direct measurements of interplanetary dust far beyond Neptune and Pluto, so every observation could lead to a discovery. And this discovery is a doozy because it suggests the Kuiper Belt might extend billions of miles farther than current estimates. Or even more mind-blowing, there could be a second Kuiper Belt beyond the one we already know about. If you're digging this cosmic mystery, smash that subscribe button and hit the notification bell. And speaking of mysteries, let me give you a teaser about something even more bizarre that astronomers have spotted lurking in the darkness beyond Pluto. We're talking about a potential planet, possibly 5 to 10 times more massive than Earth, hiding in the outer reaches of our own solar system. But we'll get to that cosmic bombshell in a bit. The Subaru Telescope discovery. Using the massive 8-meter Subaru telescope on Mauna Kea in Hawaii, scientists working with the New Horizons team have been hunting for potential targets for the spacecraft to visit. What they found instead was a population of about a dozen objects sitting at distances beyond 60 astronomical units from the Sun. That's nearly as far from Pluto as Pluto is from the Sun. These things are out in what should be empty space, in a gap between 55 and 70 astronomical units, where the original Kuiper Belt supposedly ends. Wes Fraser from the National Research Council of Canada, who led this research, pointed out something fascinating. Our solar system's Kuiper Belt has always appeared very small compared to similar belts around other stars. But these results suggest that maybe our Kuiper Belt isn't small and unusual at all. It's just that we've been suffering from observational bias, only seeing the closer, brighter stuff and missing the more distant population. Fumi Yoshida from the Chiba Institute of Technology called it potentially a major discovery, if confirmed. The exciting part is that these newly discovered objects seem to form their own distinct population, separated from the main Kuiper Belt by that mysterious gap. It's almost like finding a second neighborhood way out past the suburbs, except this neighborhood shouldn't exist according to our understanding of how the solar system formed. As Neil deGrasse Tyson has written about the Kuiper Belt, it marks the inner boundary of the outer solar system, a region where no massive planet formed and where the crumbs of solar system formation remain uneaten. But now we're finding that maybe there's a whole other region of uneaten crumbs that nobody knew about. Sedna and the orbital misfits. Let me tell you about one of the strangest objects astronomers have ever found, because it plays a huge role in this mystery. Back in 2003, Mike Brown from Caltech discovered an object he named Sedna after an Inuit goddess who lives at the bottom of the frigid Arctic Ocean. Fitting name, because Sedna's orbit is absolutely bonkers. This thing travels in a massively elongated ellipse that takes 10,500 years to complete one lap around the Sun. During its closest approach, Sedna comes within 76 astronomical units of the Sun, but at its farthest point, it ventures out to nearly 1,000 astronomical units. What makes Sedna so puzzling is that its orbit doesn't make sense based on what we know about the solar system. Neptune's gravity can't explain it. The Sun's gravity alone can't explain it. Something massive must have grabbed Sedna and yanked it into this bizarre trajectory. In 2014, astronomers announced the discovery of another object called 2012 VP113 with a similarly strange orbit. Then came more objects, each with peculiar paths that seemed to cluster together in suspicious ways. Charles Liu, the astrophysicist from the American Museum of Natural History, who co-authored books with Neil deGrasse Tyson about understanding the cosmos, has emphasized how objects in the outer solar system can teach us about the history and formation of everything we see today. These distant objects are cosmic fossils, preserved in the deep freeze of space, holding clues about what our solar system looked like billions of years ago, and what forces shaped it. Planet 9 or Planet None? This brings us to one of the most controversial and exciting ideas in planetary science right now. Konstantin Batygin and Mike Brown, both from Caltech, published research in 2016 proposing that a massive ninth planet exists in the outer solar system. Before you get excited about Pluto getting its job back, this isn't about Pluto. We're talking about something completely different. A planet roughly 5 to 10 times Earth's mass, orbiting somewhere between 200 and 800 times farther from the Sun than Earth. This hypothetical world, which they nicknamed Planet 9, would take between 10,000 and 20,000 years to complete a single orbit. The evidence comes from those weird orbital patterns I mentioned earlier. Batygin and Brown studied 13 large objects in the extreme outer solar system and noticed their orbits all seemed to cluster in strange ways. Not only did these objects point in similar directions, they were also tilted off the plane of the solar system by an average of about 15 degrees. The mathematical probability of this happening by chance is incredibly small, something like 1 in 14,000. When Batygin ran computer simulations of the outer solar system with various configurations, the only way to reproduce what astronomers actually observe was to include a massive unseen planet shepherding these objects with its gravity. Here's your mid-video reminder to hit that subscribe button if you haven't already, because we're diving into some truly controversial territory that has the astronomy community split right down the middle. Mike Brown, who you might remember as the guy who led the charge to demote Pluto from planet status, has a delicious sense of irony about this. He's been quoted saying that all those people mad about Pluto being demoted can be thrilled to know there's a real planet out there still to be found. And now we can go find it and make the solar system have 9 planets once again. The guy who killed Pluto might give us a new 9th planet. You can't make this stuff up. But not everyone buys the Planet 9 hypothesis. Some astronomers argue the clustering could be due to observational bias, pointing out that these distant objects are extremely difficult to spot, and we might only be finding the ones in certain parts of their orbits. Pedro Bernardinelli from the University of Pennsylvania noted that his team surveyed a different slice of sky and only found one object beyond 50 astronomical units, raising questions about whether everyone just got unlucky or if there's something else going on. Japanese astronomer Patrick Lycauca has proposed a different model entirely, suggesting what he calls a Kuiper Belt planet that's smaller and more inclined than the Planet 9 model predicts. He doesn't even use the same name, preferring to keep his hypothesis distinct. The controversy makes this even more exciting because it means we're genuinely on the frontier of discovery. We don't know what's out there. The Vera Rubin Observatory in Chile which is scheduled to start operations soon with the largest astronomical camera ever built, will survey the entire southern sky every few nights. If Planet 9 exists, or if there's something else massive lurking in the outer darkness, the Rubin Observatory should be able to find it within a year or two of starting operations. The Kozai mechanism and orbital shepherding. Here's another head-scratcher that Planet 9 might help explain. When astronomers look at the most distant Kuiper Belt objects, those with closest approaches greater than 30 astronomical units and semi-major axes greater than 150 astronomical units, they notice something statistically unlikely. These objects rise through the ecliptic plane when they're closest to the Sun, clustering their arguments of perihelion near 0 degrees. Chad Trujillo and Scott Shepard, who first pointed out this alignment in 2014, proposed that a massive unknown planet beyond Neptune could cause this clustering through something called the Kozai mechanism. This is a gravitational interaction that can tilt and shape orbits of smaller bodies when a much larger body is present. The mechanism would confine the object's closest approaches to the Sun at specific angles, allowing them to avoid getting too close to the Sun, hypothetical planet, even though the planet's gravity shapes their overall trajectory. Badajian and Brown took this observation and ran extensive computer simulations, testing thousands of configurations. The only consistent way to reproduce the observed clustering was to include a distant massive planet. Moreover, their simulations predicted there should be objects on orbits perpendicular to the plane of the solar system, tilted at right angles to everything else. They took this prediction to other astronomers. And sure enough, when researchers looked through existing data, they found exactly these types of objects where the simulations said they should be. This is textbook scientific method. You make a prediction, test it against observations, refine the model, make new predictions, and test those. The Planet 9 hypothesis has survived multiple rounds of this process, which is why Jim Green, who is NASA's Director of Planetary Science, said the evidence is stronger now than it's ever been. But until someone actually photographs the planet or detects it directly, it remains a hypothesis, not a confirmed discovery. What the dust tells us. Meanwhile, New Horizons continues its journey into the unknown, now traveling at about 60 astronomical units from the Sun, twice as far out as Pluto was during the famous 2015 flyby. Alan Stern, the principal investigator for New Horizons, has expressed excitement about potentially discovering a new population of bodies in our solar system. The mission has been extended through the 2040s, and with sufficient propellant and power, New Horizons could operate beyond 100 astronomical units from the Sun. At those distances, the dust counter could potentially record the spacecraft's transition into a region where interstellar particles from beyond our solar system dominate the dust environment. Think about that for a second. We could pinpoint exactly where our solar system's local neighborhood ends and the space between stars begins. The continuous dust detection also has implications for understanding collisions in the outer solar system. Every dust grain represents tiny fragments from larger bodies smashing into each other, or getting sandblasted by microscopic particles from outside the solar system. The collision rates tell us about the population density of objects, their sizes, and how dynamically active these distant regions remain even billions of years after the solar system formed. It's like analyzing crime scene evidence, except the crime scene is millions of miles across, and the evidence is floating in space. The second belt possibility. The 10 astronomical unit gap between the main Kuiper Belt and these newly discovered objects is deeply significant. In planetary science, gaps usually mean something big is gravitationally clearing out that region, or preventing objects from stable orbits there. It's the same principle that helped astronomers discover Neptune in the first place back in 1846, by observing how something was tugging on Uranus. That something could be Planet 9, or it could be an entirely different population structure we don't yet understand. Simon Porter from the Southwest Research Institute and Johns Hopkins Applied Physics Laboratory has been mapping these distant discoveries. And the data shows a striking difference between objects inside 50 astronomical units and objects beyond 60 astronomical units. What makes this potential second Kuiper Belt even more intriguing is what it tells us about solar system formation. The standard model says that planets formed from a disk of gas and dust around the young sun, and material got less dense the farther out you went. By the time you get to Neptune's orbit and beyond, there shouldn't be enough material to form anything substantial. Yet here we are, finding evidence of a robust population of objects in regions where they shouldn't be common. David Jewett, who along with Jane Liu, discovered the first Kuiper Belt object back in 1992, spent 6 years scanning the heavens before finding that first icy speck at 44 astronomical units from the Sun. He's been quoted saying the outer solar system appeared mysteriously empty, and he guessed that maybe nobody had carefully looked. Turns out he was right on a scale nobody imagined. The hunt continues. Multiple teams are reanalyzing archival data from older infrared satellites like IRAS, launched in 1983, and AKARI, launched in 2006. The 23-year gap between these surveys means that if Planet 9 exists, it should have moved slightly across the sky between observations. Researchers in Taiwan, Japan, and Australia recently claimed they found a potential candidate by comparing dots of light from these two surveys, though experts remain skeptical about this particular finding. Even if it doesn't pan out, the method shows promise for future searches. The Hubble Space Telescope has contributed by finding potential Kuiper Belt objects through its star tracking sensors, which occasionally detect brief dimming events when an unseen object passes in front of a star. These stellar occultations provide independent confirmation that there's more stuff out there than we've directly observed. Hilke Schlichting from UCLA has pointed out that there could indeed be a larger population beyond 60 astronomical units based on these occultation events. The cosmic bigger picture. What strikes me most about all these discoveries is how much we still don't know about our own cosmic backyard. We've sent probes to every planet, landed on Mars multiple times, orbited Saturn for over a decade, and photographed Pluto up close. Yet massive objects, potentially planets, might still be hiding in the darkness beyond Neptune, waiting to be discovered. Neil deGrasse Tyson wrote something profound about Pluto's demotion that applies beautifully to these new discoveries. After Pluto got reclassified as a dwarf planet, Tyson noted that Pluto went from being the runt of the planets to the undisputed king of the Kuiper Belt, the big player on a celestial campus that occupies a larger tract of the outer solar system than that spanned by the 8 traditional planets. Now, with the potential discovery of an extended Kuiper Belt, or second belt, that cosmic real estate just got even more valuable and expansive. These discoveries connect to broader questions about solar system formation and evolution. Did our solar system start with more planets that got ejected? Did close encounters with other stars during the sun's early years perturb the orbits of distant objects? How common are extended debris disks like our Kuiper Belt around other stars? The answers help us understand not just our own origins, but the architecture of planetary systems throughout the galaxy. The fact that student-built instruments like the Venetia Burney Student Dust Counter are making major contributions shows how space exploration can engage the next generation. Those students at the University of Colorado Boulder built hardware that's now billions of miles from Earth, sending back data that might rewrite our understanding of the solar system's extent. So here's where I leave you with the cosmic cliffhanger. Somewhere out there beyond Neptune, maybe 500 or 600 astronomical units from the Sun, maybe closer, maybe farther, there might be a world 5 to 10 times Earth's mass tracing a bizarre orbit. Or there might be multiple smaller worlds. Or there might be a population structure we haven't imagined yet. But something is out there making the distant objects dance to its gravitational tune. within the next couple of years, we'll probably know the answer. Either Planet 9 will appear in Vera Rubin Observatory images, swimming into focus as the giant telescope surveys the southern sky night after night, or it won't, and we'll have to explain the observations some other way. Either way, we're living through a genuine age of discovery in our own solar system, the kind of frontier astronomy that rarely comes along. If this deep dive into the mysteries of the outer solar system scratched your cosmic itch, then you know what to do. Hit that subscribe button, smash the like, and turn on notifications so you're here when we confirm or debunk the existence of Planet 9. Drop a comment telling me what you think is out there beyond Pluto. Share this with your space nerd friends. And remember, the universe is not only stranger than we imagine, it's stranger than we can imagine. See you in the next one, Space Explorers.